Hello. I have a couple of more things to say about the transport layer. Not much in this one. After this, I think I'm going to talk about Wireshark's abilities. We have talked about the idea of the sliding window. Well, the sliding window determines how many we can send. It depends on our storage space. What about the receiver? The receiver is storing the files as it gets them, and we don't want to send faster than the receiver can receive them. So the receiver is going to send us it's called an advertisement of its free buffer space. This is called the receiver window. The sender now won't send more than the receiver window, even if its sliding window is bigger. So that controls congestion at the receiver. But we got another problem. Along the way, the routers are saving the messages, the packets. What if they get overcrowded or congested? Well, to handle that, we're not going to get a message back from them. They're not going to tell us anything. We don't even know which router is causing the problem. So the only way to handle that is to rely on what we can see. The ACKs that are coming in, lost messages, timings. So the sender is going to create yet another window, actually the size of the window, and this is going to be the congestion window. The sender is going to send the minimum of the send menu of its own sliding window, its receive window, and its congestion window. That's going to, whichever one of those is smallest, that's all it can send. I have on the line at one time. Now, how does this start? When you start, the sender begins with a slow start. It sets the congestion window to 1. When an ACK is received, it adds 1 to the command window. Now, the strange thing is this is called doubling the size of the command window. And it might be hard to see this. It looks like it's just adding 1. But here's the explanation. We start with a command window of 1, and we get an ACK back. We add 1. So now we have a congestion window of 2. We send out 2 items, and we get back 2 ACKs. And for each of those ACKs, we add 1. So now we're up to 4. That's the double. Then we send out 4 items, and we get back 4 ACKs, and we get 8. And that's why it's called doubling. At first, that seems hard to understand. Now, there's a point where the slow start stops. Some threshold we set that says when we get to this point, we're not going to keep adding. We've already got enough. After that, we now increase the congestion window linearly. We only add a little. That's additive increase. So it's just going to increase by 1 or something like that. But when we get a lost packet, we cut the window in half. That's drastic, but we're saying packets are getting lost. We better watch it. That's called multiplicative decrease. And those two steps are called AIMD. Additive increase, multiplicative decrease. Now that ends the transport layer. You notice what we've done so far. We've talked about mostly TCP. We mentioned UTP. We showed it used in the DNS. But the TCP has lots of little pieces to it. The sliding window protocols, the congestion control, the flow control. We talked about the three-way handshake to begin, the four-way handshake to end, and all these flags like acts and sequences. Remember that when we're assuming that both sides are both senders and receivers. So when we send something, we tell the other side what our sequence number is and what we're acking from the other side, what we expect to get from them based on what we've gotten already. And by going back and forth with each of us verifying what we received, the two of us can keep on track. We don't lose things, hopefully. As we've done two layers so far. The applications layer connected a program to a program. Transport layer connected a host to a host. Like a socket to a socket. We sent to socket 80. And then socket 80 was the TCP protocol that had to figure out where to put something. Or the HTTP protocol. Now, what about the in-between? So far, we haven't touched the intermediate portions of the internet. That's the internet layer. And that's what's coming next. So that's where I'm going to be right now. I'm going to be talking a little about the Wireshark in a short while, and we'll see how that interacts with this. Good luck now. Bye.